So I'm recording this for length and as a means of review for myself here. This is class 3 of ME401 501, and we're going to deal with 4-bar linkages and the graphical position analysis. As my recollection is, this class took much longer than I anticipated last time I gave it, so we might have to extend it into class 4. One of the reasons why I'm making this video. So let's see. These are going to cover Norton's section 2.18, 3.3, 4.4, and 411 through 412. That's one of the reasons why it's a long one. 4-bar position analysis and practical considerations. Homework 2 is not due in the next class. That is a mistake right here because it's going to. So anyway, so graphical position analysis. So Norton typically uses lowercase letters to designate link lengths, right? So they'll use lowercase a is most often going to be, I believe, the crank, which is kind of weird because a lot of times it'll be link 2, right? I don't know, but just note that he uses the length for this first crank, right? This first link right here as lowercase a. But this is they'll use theta 2 for its positions, theta 3 for this link position, theta 4. And the theta is noteworthy. They're always counterclockwise from positive, from the horizontal right there. For most analyses, the link lengths are known. The ground link angle is known. Quite often it'll be 0, but it doesn't necessarily have to be. And the input link is given, right? So that's like the, so a lot of times we'll know what theta 2 is. And so what that means is there's really 2 angles left that are unknown. It's going to be theta 3 and theta 4, right? And unfortunately, there are 2 possible positions. Given this information, right, knowing all the link lengths, knowing the position of the ground link, and then knowing the position of the crank input link, there's 2 possible spots this could happen, and quite often one of them is open and one of them is crossed right there. And you can see from this figure right here, this is the open one right here with the darker line, and this one with the hatched line, or the dot dash dash dot. Dot dot dash, whatever, that line right there, that's the crossed version for these 2 possible configurations. So we can do this graphically. We could show how these work out. It's really good to use a compass. So I should have told you to acquire a compass. I think I did at some point. Hopefully I should have probably really emphasized it. It's a really good idea to have a compass to be able to figure these things out. And so I'm going to switch over to my camera right here as part of this explanation right here. So if you know the link lengths, so let's say that this link right here, link 3 is this long right here, and we come up to this point and we draw, right, our arc, right? I didn't do a great job of getting it right on top of this thing, so I'll maybe make it a little bit bigger and make it a little darker. It's really easy with compasses to mess the thing up right there, right? So I guess I got that pretty close. And then we know that the link 4 right here, and it's kind of close. I think I made this with yeah, it's close right there. I think I might have eyeballed it. We can see where they cross right here. They cross at this point and that point. So we have a possibility of being right here. Let me see, did I do that right? Yeah, I think so. doesn't look, where I put the thing doesn't look quite right. Yeah, I guess like right there. All right, so it could be in this configuration, or it can be in this configuration. And of course you see it up here, right? So here's the one that's open, and here's the one that's crossed. Now that that position isn't like, it has to be arranged that way originally, right? It isn't that it can move into that location. So like if I were to take my my little demonstration unit right here, and maybe this is me riffing, so this is where my time goes, right? So maybe we should learn from our mistakes. But I'm going to put in my 85 millimeter my 85 millimeter link, so that, okay, so looking at this, we could either arrange it this way up here, or we could put it together down here, right? So this is the, we'll call this the crossed version right there, right? So a lot of times this will be like, let's say that this is an input angle. Well, actually this is the input right here. So let me maybe change it over here, right? So here's the input angle of like 30 degrees right there, right? So we have as a means up here, we have that it could be connected up there, or it can be connected down here, right? So that's what we mean by there's two possible positions for a particular set. And I'll tie these back together before I'm gonna put it away. Not very exciting stuff, is it? But once again, I'm trying to time out the lecture in practice. Okay, so yeah, we'll see this happens mathematically too, right? So just be on the lookout for that excitement. So here is an example right here for the 4-bar position graphic analysis here, where we're going to take the ground is 3, the input is 1 long, the coupler is 3.5, and the rocker is 4.5. And first thing we should do is check for Grashoff, so that the longest one here is going to be 4.5, right? Yeah. And the shortest one is, of course, the crank at 1. And the other ones, we call it P and Q, and it doesn't matter which one's which, are 3 and 3.5. So L plus S is equal to 5.5, and P plus Q is equal to 6.5. And it's because this is less than this, right? So we can say that L plus S is less than P plus Q, therefore Grashoff. And since S is the input, we have a GCRR, right? And so I try to put this in here. What I'm going to say is that each of these blocks is going to be equal to 1, and we haven't really even decided what our units are onto this. So I think I picked this right here is going to be one of the spots, and right here, right? So there's the ground link, and if we're numbering and lettering these things, I guess we decided, okay, that's fine. So that right here is the ground situation, And here is the angle of the input is 30 degrees, right in there. So if I was going to do that with sometimes I use, did I include? I should have included I should include them. I should bring those to class. Here you go. Alright, so maybe I should also bring that to class. This would be a nice little thing here. And here's a nice compass too. Alright, so I can bring all those things. Sure. So we have our 30-degree input right here. And let's see if we can do this. Here's 30 degrees, and these things don't come out to be any particular size, do they? Oh, that's pretty close to half an inch. All right. So, and we could also use, if we're very careful with them, of course, this lead is really dull right here, but we could find that is one increment right here, so we could come up and carefully put that right in there. So that's the length of this. And maybe being this, it would be nice to have the thing to be bigger. And my office hours are still going on. Oh, they should, yeah, 11 to 12:30. I should be done. Okay. So did I label this one? Not yet. I'll label it here in a second. So here's the possibilities here. We have 3.5. 3 is going to, the coupler's 3.5, and the rocker is 4.5. So here's 3 and change right there, 3.5. So this thing could be anywhere like up here, right? Kind of. Am I still there? Yep. Okay. It can also be down here somewhere, right? So we're not really sure. So we could actually, if we just make it a bit full thing up to the circle, like right there. Okay. And then, so let's make this 4.5. And that's going to be from here. So we're going to see that right there it's going to connect, and right here it's going to connect. So we have a possibility of having it come up from here to there, and from right here to there. And that is a possible location. It could also be from right here to right there, or right here. So here's the possible configurations that this thing can land in. And if I was going to label this, this is link 2, this is link 3, this is link 4, and this is the ground link, link 1. And a lot of times for this, we might maybe make this dashed right there. So we might run over that again and make that look like it's dashed. So this is the crossed configuration, and by crossed we mean it's crossed right there, right? And so this, I think we call that 3 prime, and this is 4 prime is in the designation in the book. And if we were going to communicate what the angles were, right, well, this one's 30 degrees, but here what we do is we draw from horizontal at this spot, and we measure from right over there. So there's like theta 3, but then, and I don't want to draw over this because it's going to make a mess, but we would come around and would come all the way down there. So it would be from all the way over here all the way to down there, and that would be the theta 3 prime, right? And then, so for this rocker, we'd have that was the theta 4, but we also have the possibility of over to there, theta 4 prime. And so graphically, I might estimate that this angle right here is okay. So okay, now actually, they're saying, I'm sorry, I wrote this down wrong. This angle right here, we call that angle theta 3-1, and this is theta 3-2, whereas this is theta 4-1, and this is theta 4-2, right? And so the second digit is describing the alternate location, right? So there's theta 4-1 right in there, right? And as part of this, I don't quite like that they're saying that that's 67 degrees. That doesn't look like this. They're saying it's 265 degrees. Is that true? I don't like what I've written here. I'm graphically estimating 265. So how long is my video already? It's probably too long, isn't it? I think I would say that theta 3-1 right here, I would say theta 3-1 was graphically estimated to be somewhere a little less than 90 degrees. Doesn't it look like that way? I almost think it's like 85 degrees. I would say so, 85 degrees right in there. And if I was going to say theta 3-1 or 3-2 right here, I might come back down here and try to get that aligned horizontally right in there, and we're gonna go 180 plus. That's close to 60 there. I think it is pretty close to 60. I would say that it was 180 plus, let's say 62. 180 plus 62. 180 and 62. I can't add it together. It's 242 right there degrees in the theta 2 position. Estimate theta 4-2 as being something like right around 105 degrees. So I mean theta 4-1, 105 degrees, and then if we're going to go for theta 4-2 here, it looks like it's somewhere 32 degrees plus 180. So that was that. Is it a 232 and 180? So 212. So that was right here. 212. So let's take a look here in Solidworks. I'll make a new sketch. So I'll make a new part, I should say. So I'm going through here and make it into this sketch right here. I'm going to make a horizontal line, capture it in there. I'll make it 3 long. We will make a line like right there and make his length 1 and put him in there, make it at 30 degrees. Okay. And we'll put this guy right there and him right there. We could also, so here's our first configuration right there. And this length is, what did we say? That was 3.5. All right, and then this is a length of 4.5. All right, and so this right here, it's going to be, this has to be a driven dimension. Yeah, we got like 88. Yeah, so what's close to 90? So that was driven. And then from here, I'll make also a horizontal reference. From here to there, 117. I said 105. That wasn't very good. How did I get that 105, 117? How did I get that so far off? Oh, I see. Okay. Yeah. I messed up. So there you go. And why was that 105? I guess I was counting the wrong way. There's I guess graphically, actually, I have it like 114 right in there. Okay. And then like graphically up here. Yeah. Yeah, I guess it's more like 88. Yeah, you could see that it's more than 85, right? It's somewhere in there. And then let's see here, by way of get the right one here. What's going on? Okay. I'm going to use, let me use center lines right here. So in this configuration, we're going to be down here and down in there. And so this should be 3.5, right? And this should be 4.5. And so our position analysis off of this to right here, 244 compared to our, what I thought was going to be 242. So it's 244 versus 242, not terribly bad. And then this to right here is 216 versus what I said was going to be 212 right there. So I just changed this one up to 112 right there. So there's a graphical position analysis to try to figure out where that's going to be with it, that input. I'm at the 22-minute mark, which is kind of long for a video. I'm going to continue though. This is continuing on with this example right in here. I want to update my estimates on my other page right in here. Not that you care, but so I said it was 85-ish and 242-ish and 112-ish and 212-ish, but we could do a better job in that next time. Okay. Now we have one that's going to be non-Grashoff on purpose, so I figured I'm going to do one of one and one of other. So we first check our Grashoff condition, and our longest one now is 5.5. Right? And our shortest one here is 3. And then, so the other ones are going to be 4.5 and 3.5, right? Yes. So 3 L plus S. I forgot to eat lunch. My stomach's grumbling. 3 L plus S is didn't write it down. 8.5, and P plus Q is going to be 8. And since L plus S is greater than P plus Q, it's therefore non-Grashoff. And since L is the coupler, the longest one, let's see, the longest one is this guy right here, and it's the B, which is the L3, is the coupler. Therefore, we have a rocker, 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 3 according to that table in Norton. So let's make the longest one is, let's see, make the ground is 3 right there. Is that true? No, the ground is 4.5. Sorry. So I'll start off over here. Is going to be enough room. And there's 1, 2, 3, 4 right there. Whoops. So I'm not starting off on the right foot. Let's leave it there. And our input is 3.5 long, and it's at 60 degrees. So let me find out where 60 degrees is going to be. It's like right in there. Something like that. And did I say that I get the, well, I'll use maybe I'll use the new compass. We'll see how good it is. I've had some seriously bad compasses. That one has a pretty dull looking thing on it as well. Yeah, I need to get like a sharpener for those leads. I don't know how to do that. Maybe one of you can show me how to do it. That's good. Let's see. I'm going to pick out 3.5. All right. So there is the length right there of the input. I'll darken this up. And now we're going to have a coupler of 5.5. So hopefully we've been able to get this thing to stick. So there's 1, 2, 3, 4, 5. All right, to there. So it's going to run off over, well, I could just make a big arc. Make a big arc over there. And then the rocker is only 3 right here, right? So let me move this thing back. To 3. So he's going to have a configuration right there and right there. So here is going to be the non-crossed position of these two. And then right here is going to be the crossed version. So and then yeah, down here. So labeling these things, I guess this was 2. This was 1, obviously. This is 3. This is 3 prime. This is 4, and then this is 4 prime. The angle, input angle right here is input angle was our 60 degrees. Graphical estimation here, I'm writing it over here on the side, is I had theta 3.1 is approximately, okay, so we have to subtract, let's go here and subtract from 360, so it's something along these lines right here, and coming through, let's see if I got that lined up. I think I got it lined pretty up well. So we see that that comes up to like 80 right there, right? So we're coming from here, so we'll subtract 3 80 from 360 was at 280, right? So I'm going to say that I got something like approximately 280 degrees. And theta 4, okay, so now what I want to do probably is kind of have to kind of like mentally extend this. It's not going to be the greatest. It looks like it's coming past 30 right here, so it's actually coming like that here, maybe to, let's call it 32. So I'm going to add that to 180, right? It's because that's going to come, you know, from the horizontal. I didn't draw the horizontal in there, but it's going to come all the way over to there. So 180 plus the 32 should be, that should be 212 again, right? Silly that I have to add this in my calculator, but 212. So that's going to be my theta 4, 1, right? Because it's the 1 configuration. So I'm going to say 212 again. And then for my horizontal, let's see, take the horizontal right here. And that looks like it's past, no, am I doing this wrong? Yeah, I'm doing this wrong. I'm going to come to right here. I wonder if I did that wrong on the other one. No, it's from right there. You can see here, we'll subtract it from 360 then. So like right in there, let's say, sure. And so here is counting over this way. It's like a little less than 80. Let's call it 79. So 360 minus 79 was 281, right? So there's, is that right? No, I'm looking at the wrong one right here. Yeah, I accidentally counted this one over here. So this is theta 3, 2. Yeah. Let's go back. That's the 280. I'm going to go back over this one. It's this one that I wanted right here, right? And so putting that guy right there as best we can and looking, that to me almost looks like it's close to 15 degrees. So we're going to subtract 360, subtract 15 from it, we get 345. I'm going to say 345 degrees. Okay. And then theta 4. Yeah, theta 4. Okay, so I messed up on that one too. Wow. Not paying attention. We need to do it from the base right here of that. And so that's going to come up this direction. It's almost 30 degrees. It's like 32 degrees right in there, right? So that's like 32 degrees. And then lastly, if we can keep our heads on straight right here, an example of what not to do. We're gonna, I guess I'm gonna come up, I'll go this way and then, no, I guess I'll go this way, right? Coming around right in here, we find this one looks to be like 100, almost 130, 100 and let's say 128. So we're going to subtract that from 360. And we're going to say that that's going to be 232 degrees. Theta 4, 2. So let's see how we did with a SolidWorks model instead. We'll just be done with that one. Let's make a new one. 33 minutes. All right, so we start off with our ground here. And our ground was what? 4.5? And we have a 60-degree angle here with a length of the input is 3.5, right? And we have an 60 degrees. Now up in the open position here and here, once we establish these lengths, it's fully defined, and the length of that is 5.5, and the length of this one right there is 3. All right, so that's the configuration that we were seeing right here. And let's put in horizontals. This is the location about which we measure angles there for right here. So let me come around this way. That's okay, and that's driven. So 344. Yep, the close. We had 345 when we eventually got the thing the right way. And for this guy, yeah, we measure from here. We have nearly 32. Yeah, just about right. So let's look at the other configuration. I'm going to treat this one with construction lines. Hopefully I didn't make that no, okay, that's fine. So that this one is going to be 5.5. And then this one is going to be 3. Okay, so that is the configuration, and we take a look and compare it right here. Yep, looks pretty good. Sure. And now making a comparison, I could go ahead and, oh, I messed up. No, I messed up. Whoops. Yeah, darn. Oh. I should have gone from here to down there. Okay. Now that should be 5.5. Yeah, okay. That looks right. And so let's see, measuring the angle, once again from here to right there. 280 degrees, yeah, 280 degrees. That wasn't too bad. And then this last one from here to right there, 232. Yeah, so we had 232, and we had 232, right? So we actually didn't do too badly in this second one. So this is graphical position analysis of a 4-bar. And one of the reasons why we're doing this is because we're going to do analytical analysis, and I know that's a weird phrase of the thing. I didn't come up with it. By the way, it says to do the same thing here, right there. So that's what we just did. When we do analytical analysis, we'll see that it's not as easy to think. It's actually position analysis by way of using equations. It's actually kind of quite challenging. So there you go. That's our long video, 38 minutes. But we're going to continue with the rest of the class.